Hi, my name is Vicki Bogdan, and this is my Lab 3 video lab report on black holes. So the problem we had was we had to determine the mass of a black hole exerting a gravitational force on a star. And we also related FNet parallel and perpendicular to dp/dt parallel and dp/dt perpendicular. So the outline of what I'm going to go over is my results and gravitational force calculation, physics principles used, my VPython model, the what if question, and what does it mean. So the result that I got is that the mass of the black hole is 3.95 times 10 to the 31 kilograms. So I figured this out using Newton's gravitational law. The VPython model helped calculate the net force, and I solved out this equation algebraically for mass 2. So in Newton's gravitational law, G is equal to 6.67 times 10 to the negative 11. M1 is mass of the star, M2 is mass of the black hole, and R is the position of the star minus the position of the black hole. So the physics principles used were that dp/dt is equal to dp/dt parallel plus dp/dt perpendicular. And dp/dt parallel is speeding up or slowing down, and perpendicular is changing directions. And we also use Newton's second law, shown here. So in my code, I had that the mass of the star was 1.989 times 10 to the 30th kilograms, and my delta t was 86,400 seconds, which is equal to 1 day. In my calculation loop, we calculated the net force from motion, and we computed initial and final momentum vectors, and we calculated the star's change in velocity and also the change in momentum, and then we calculated dp/dt, we calculated the net force, we used Newton's second law to calculate FNet parallel, we calculated dp/dt perpendicular, and then we used Newton's second law to calculate FNet perpendicular. So what does this mean? How are FNet parallel and FNet perpendicular related to dp/dt, dp/dt parallel, and dp/dt perpendicular? So as shown in my code, FNet parallel is equal to dp/dt parallel, and FNet perpendicular is equal to dp/dt perpendicular. So how are they different? Well, as shown in the momentum principle, one is the change in momentum over change in time, and one is that represents the net force. And in my Python code, the black arrow is the dp/dt parallel, the blue is dp/dt, and the yellow is dp/dt, and the blue is dp/dt perpendicular. So what if, imagine the black hole whose mass you found was removed and a different black hole was placed in the same location, assuming that the motion of the observed star remained unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? So the answer to this question is yes, we can determine the mass because we can find the acceleration and the net force, therefore we can always solve for a new mass. Thank you very much.